Arun's pin has 4 digits, so I'm going to call it A, B, C, D. And then when the first digit, reading from the left, is moved to the end of the pin, so it would become B, C, D, A, the resulting integer is 6 less than 3 times Arun's pin. So what I did in this question, I actually did it. I always get into this habit of just writing it using thousands, or hundreds, tens, and so on. And I'm going to show you how to do that. But there is a quicker way you could have done it, which I'm going to learn from in hindsight and maybe use in the future. But this is a good strategy anyway. When if you're not ever sure, change digit format into just like 3,127 is actually 3 times 1,000 plus 1 times 100 plus 2 times 10 plus 7. We can basically do that for this more general number. It's going to be 1,000A plus 100B plus 10C plus D. And then we can do very similar for the BCDA. This will be 1,000B plus 100C plus 10D plus A. But I've not yet, so they're not equal. And this is where you've got to be really careful. The resulting integer, this one here, is 6 less than 3 times Arun's pin. So I actually need to times Arun's pin by 3. That's what it's saying. And that gives me something that is 3. The resulting integer is 3 times Arun's pin, but actually it's 6 less than that, so I put a minus 6 here. So I can set these to equal to one another. I've created an equation. Remember, we know that A, B, C, D are all they're all digits. They're not necessarily different, but they're all going to be between 0 and 9. So let's multiply this out. 3,000A plus 300B plus 30C plus D minus 6 equals 1,000B. Obviously, try and write this all on one line, but I don't have space here. Okay, now I'm going to basically, sort this out, get all the A's on one side. So I'm going to get them all onto the left-hand side. So it's going to be 2999A and then minus 700B minus 70C. I forgot to times that D by 3 there. Hopefully you spotted that. So minus 7D is gonna, I'll just get it equal to 6. Okay, here we go. When I did this next part, maybe I should have filled in more details. I probably would get penalized for it. I said that A has to equal 1, 2, or 3, because I just recognize that I'm timesing it by 3. So if it was like 4, then it would already be like 12,000. There's no way I could subtract a number. I think we can actually do it better than that. You can even say that A has to be 1 or 2. It can't even be 3. A way to look at it here, I guess, is that B has to be less than or equal to 9. And therefore, yeah, this is probably a bit better. 299A. So if I added 700B onto both sides, so this will have to be less than or equal. So this would be 6,300. So 6,306. I've ignored the C and the D terms because I'll be subtracting them. But we can clearly see from this that A has to be 1 or 2. Okay, so actually I've done a bit better this time. I just went straight for it because I kind of just knew intuitively that it had to be 1, 2, or 3. But we don't even need to check 3, and I've shown it here. So I'm going to look at the two cases now. Case 1, A equals 1. Then I'm going to get 2,999. I'm going to minus 6 from it. So that's going to be 2,999 293, and that will equal 700b plus 70c plus 7d. Now remember, b, c, and d are integers, so I'm trying to get an integer solution to this, and I can clearly see the right-hand side is divisible by 7, so it must necessarily be, if there's solutions, that the right-hand side is, sorry, the left-hand side is as well. So 7's into 2993. We get 4, remainder 1, 7's into 19, go 2, remainder 5. Okay, this is going to be 7, remainder 4, so not going to work, no solutions. So we can bet that this has got to give us a solution. If it doesn't, then would have made a mistake somewhere. Case 2, a equals 2. So this time, right, let's just take it a little bit slower. So 2999 times 2, well, 3000 times 2 is 6000. I just need to then subtract 2. So 5998. And then I'm going to minus the 6. But just before I do that, let me put this line in. Okay, and again, we can divide through by 7. So 7's into 59, go 8, remainder 3, and 5, remainder 4, then 6. So 856 is equal to 100b plus 10c plus d. And remember, b, c, and d are all single-digit integers, so it kind of falls out from here. b must equal 8, c must equal 5, d must equal 6. And the pin must be 2856. Now let's take a look at a quicker method. My method works pretty well here. It takes a little bit longer than this quicker method, but for questions where you have an increasing number of digits and this sort of thing happening, this is worth knowing. So actually, because I'm really only focused on A moving, I can write the pin as 1000A plus some other number. Let pin equal 1000A. I'm purposely not going to use B, C, or D now, actually. I think I'm going to use F just because I don't want to make it look like it's the same thing. A is that first digit, but now F is like the remaining amount. So A is between 0 and 9, and F is between 0 and 999. So then we move A, remember A, B, C, D goes to B, C, D, A. Okay, but this thing is my F now. So I've got 1000 A plus F over here. And now I'm actually timesing F by 10 to get this, and then I'm adding A. Okay, so that's how the pin is changed using this notation. I think it is a little bit more confusing, to be fair, but quicker if you understand it. And then remember, it was 3 times the original pin, and then we have to minus 6 from it. So I've got this equation instead, and actually just these two unknowns rather than the 4 I had before. So in the same way, I'm going to multiply it out. 3000A plus 3F minus 6 is going to equal 10F plus A So this time I'm going to write 2999a minus 6 is going to equal 7f plus a. Now remember, I said that f is between 0 and 999. So this is essentially going to be less than 8,000. It's a bit of a rough argument, but maybe I should say 8,000 plus a or whatever. But again, we can see that a is equal to 1 or 2, because otherwise it would be too big. And then at this point, actually, we get into the, sorry, why have I still got that plus a? Apologies, that should not have been there because I minused it. Sorry. It's a lot neater then. Yeah, so I minus the a to give 299a and minus 6 and minus that. This is all good. F is between 0, less than 1,000. So this whole thing is less than 8,000 for sure. So a has to be 1 or 2. And at this point, we can then just look at the two cases. A equals 1. Do you know what? I'm just going to carry on with it. A equals 1. So that would give me 2993 equals 7f. And from that, you do the division in the same way and see that it doesn't work. And then a equals 2, which is going to give that 5998. And then we minus the 2 from it, if I remember correctly. Yeah, equals 7f. Now, if we do the division, we get f equals 856, and it works out in the same way. So, two different methods. Yeah, I still kind of prefer mine, but I see the merits in the second way. I think it's maybe easy to make a mistake, but if you're on point with it, it's definitely quicker.